saw your question about this exponential equation, and I hope I can help out. This one's pretty tricky. It's kind of a harder type that you can see. I do want to mention at the beginning that in some cases, when the base of these two sides, so the 7 and the 8 are the bases, when those numbers have a common factor, these problems can actually be a lot easier. You happen to have a harder example where 7 and 8 don't share any factors besides 1. So I just wanted to point that out at the top, that requires some more difficult strategies. So what we're actually going to use to solve this one is this logarithm power rule that I have listed down here at the bottom right. And that may be a little weird here at the start because this problem doesn't have any logarithms. So where in the world am I getting that? Well, this is actually just a trick you can use anytime you want to solve an exponential equation like this where the variable is in the exponent. And the first step of that trick I've already written right here. And that's just to take the same exact equation and take the log of both sides. You can do any logarithm you want. This is log base 10. When you just do log and there's no number, it's automatically a base 10, and that means there would be an invisible little 10 right there on both logs. You could just as easily do log base 2 on both sides or anything else. It does not matter just by nature of how logs work, but it's pretty common to use the common log with the base 10. All right, and so the trick here is that if we do put a log on both sides, then that means we're able to use this log rule. And that's so valuable because the whole essence of this rule, if you look at it, it says log base b of x to the y power can be equivalent or equal to y times log base b of x. So essentially all you do in this rule is you get to take that exponent y and bring it out to the front. And that's really important here because the variable that we're trying to solve for, the x, is stuck in our exponents. And so this gives us a way to get that variable out of the exponent to help us solve it. And so that's the first step, is just to throw a log in front of both equations and then use this rule. So that's what we're going to do. We're going to take the exponents here in each case and just throw them out front and multiply by whatever's left with the log. Now you do have to be careful in a case like this because the exponent is two different terms. So just make sure when you pull that out front, we're going to put that 9x minus 8. Please excuse the handwriting. All of that needs to go in parentheses because all of it needs to get multiplied now by the log of, and we're left with 7 on the inside. So that's our left-hand side. And then we'll do the same thing on the right. We're going to write in parentheses 5x minus 6, and then times the remaining log, so log of 8. Okay, and that first couple steps is super important because now our x's are out of the exponents and it's going to be easier to solve. So where do we go from here? There's still a lot going on. And in fact, the term that we're looking for, the x's, are still stuck in parentheses. So at this point, we're going to get rid of those parentheses. We're actually going to distribute the logs into those parentheses so we can get rid of the parentheses. So normally when you distribute, maybe the term you want to multiply is in front, but it doesn't really matter. I'm going to multiply this log of 7 into the parentheses, and I need to distribute to both of those terms. So 9x times log of 7 and negative 8 times log of 7. Now for this first term, I'm going to rearrange the terms a little bit. I'm going to put 9 log of 7, and then I'll put the x at the end. And the reason for that is just like you put the 9 in front, your number, log of 7 is also just a number. So it's pretty common to put both of those numbers being multiplied at the front. You could type log of 7 into your calculator and it'd tell you exactly what it's equal to, and then put the x at the end. And then for the negative 8, I'm just going to put minus 8 times log of 7. Now, like I said, you could put that into your calculator, negative 8 times log of 7, see what you get. I wouldn't, because it's going to give you a really messy decimal, and then you got to have that thing floating around the whole time, and it's just going to be a mess. So It's way easier just to leave stuff like it is, leave the log there, and save it to the end. All right, next up, we're going to do the exact same thing on the other side. So multiply this log of 8 into the parentheses. So I'm going to put 5 log of 8, again, putting those two numbers next to each other, and then times x at the end, and then minus 6 log of 8. And technically that's 6 times log of 8. So now we've got all our parentheses, or the big ones, taken care of, and now we just need to get our like terms together. So just like you would if there weren't any logs around, we need to get our x's together, and we need to get the terms without x's together. So what I'm going to do is I'm going to take this first term, this 5 log 8 of log of 8 times x, and I'm going to bring that to the left-hand side with the other x term. So I'm gonna, this is a positive 5 blah blah log of 8 blah blah blah. So I'm gonna subtract that. On this side, it'll cancel, and I also need to subtract it on this side. Now I said like terms a minute ago. These aren't technically, yeah, they're like terms because they have an x, excuse me. But what I mean to say is we won't be able to really simplify all that much because the log of 7 and the log of 8 aren't the same. So we can't, for example, do 9 minus 5 is 4. So what we'll have to do is we'll just write 9 log of 7 times x minus, we'll just write them next to each other, minus 5 log of 8 times x, and we'll be able to do one little trick with that here in a second. Now, I'm also going to go back up here, and I'm going to add 8 log of 7 on both sides. So we'll cancel that, and then 8 log of 7 on this side. And again, even though these are both numbers, 6 log 8 and 8 log 7, we can't just add those together. We can't do negative 6 plus 8 is 2 because the logs aren't the same. So on this right-hand side, we'll also have to just write the two of those together. So negative 6 log of 8 and plus 8 log of 7. Or you could flip them if you want, the 8 first, the negative 6 second, doesn't matter. Now only a couple more steps to go here. The next one is sometimes a little weird for people. In a case like this where, like I said, you can't just put those terms together, like if this was 2x and 3x, you could just do 5x and put them together. But in a case like this where there's nothing you can do with these two coefficients, one way to get around that and still combine your terms is to just factor out the x that they have in common. And so that means we're going to put an x on the outside of parentheses. So we're dividing out the x here, and we're dividing out the x here to put that on the outside. And on the inside just goes whatever's left. So we put 9 log of 7, and then minus 5 log of 8. And on the right-hand side, nothing's going to happen because we can't put any of that together. So all of this, I wonder if I can, nope. All of this will just stay the exact same. So negative 6 log 8 and plus 8 log 7. And if you're wondering, like, well, why did you factor out that 7? You just went through all this trouble to get parentheses, and now the parentheses are back. Well, here's the last little trick. I'm trying to get x by itself. That's the whole point here. So notice what we did. Now I have x times all of this mess. Everything left on the left-hand side is being multiplied by x, everything that's not x. So what we actually get to do here is divide, because we're trying to isolate x. The opposite of multiplying is to divide all of that stuff, and we can do it all at once because it's all being multiplied by x. So divided by 9 log 7 minus 5 log of 8. All of that will cancel. We'll do the same thing over here. 9 log 7 minus 5 log 8 of 8. And notice that is our answer, because the only thing left over here is the x. It is not by any means a pretty answer, but that is the final result for x. And there are a number of different other log rules you could apply here to manipulate it, make it look a little different. But at the end of the day, this is the answer you should get. It should be equivalent to about 0.434. And no matter how you manipulate this thing, no matter how many log rules you apply to this answer, the value of 0.434 should not change. So you have a pretty difficult problem here. It requires a lot of steps, but at the core is you're applying this log rule. That has to happen first, and then the rest is just a bunch of algebra. So I hope that helped, and good luck with the rest of your problems.